Welcome. The following video consists of a three-part walkthrough on idealized generic application of life cycle assessment with geosynthetic materials. For this example, we'll use template number 3, which covers scenarios of different retaining wall solutions. Most of the data was taken from previous environmental assessment carried out by Stuckey, Fraser, and collaborators. The function of our structure is to act as a retaining wall while being a steep, durable, and stable solution. For this, the functional unit has been defined as 1 meter of running length of wall, of a 3 meter high structure, and a service life of 100 years. The alternatives include a gravity wall using reinforced concrete and different geosynthetic reinforcer walls, including polypropylene and polyester geogrids, as well as polyester geostrap reinforcement materials. For this example, we'll consider a cradle-to-build scenario, in which no deconstruction or waste management stages are considered. Having defined our project constraints, we continue with the lifecycle inventory. For the gravity wall alternative, we'll need to include on-site excavations, concrete for the cleanness layer and the foundation, as well as the concrete and reinforcing steel for the wall itself. The inside face of the concrete structure is covered with an insulating bitumen. Additionally, we must include the formwork and drainage elements. For the reinforced soil walls, inventory elements include the facing, composed of a geosynthetic layer covered with sprayed concrete, the geogrid materials, be it polypropylene or polyester, the backfill material, assumed to be obtained from the construction site, and the drainage elements. For the geostrap alternatives, the inventory differs mainly in the facing elements, for which we'll have discrete concrete panels. All reinforced soil walls include the use of heavy machinery for the extension and compaction of the backfill material. The following video will cover the input of all the data in the one-click LCA software.